Greetings, Math 107 students. I've heard from some of you that there is still a little bit of confusion over how you interpret a confidence interval. So we're going to take a look at some valid and invalid interpretations and also the specific meaning of a percent capture rate. So before you even interpret an interval, we want to make sure the conditions have been met. Notice for proportions and means, the simple random sample or random sampling method must be met. So we can't ask our friends, for example, how many hours they spend gaming in a week, especially if our friends are into gaming. That wouldn't be very representative of the population of all students at Moravian College, for example. So we want to make sure that condition's been met. And then we also want to make sure that the normality condition's been met. And so let's take a look at an example where possibly one of these conditions hasn't been met. Here, it says a doctor is measuring the mean systolic blood pressure of female students. It says the blood pressure is known to have a skewed distribution, and the doctor collects systolic blood pressure measurements from a random sample of 28 female students and gets a confidence interval. Which one of the following conclusions is valid? And notice that the right answer here is that the sampling distribution of means will probably not follow a normal distribution, so we cannot draw a conclusion. And the reason for that is because our sample size was small, 28 female students, and the original population distribution was known to be a skewed distribution. So that is why we can't even make a statement like the one that's listed above it. If we had a larger sample size, a sample size more than 30, then we wouldn't have to worry about the original population distribution being a skewed distribution. And the statement that's listed there, we are 90% confident that the mean systolic blood pressure for female students at the college is between those two values, would be correct. So what is the meaning of the confidence level, whether it's 95%, 99%, or 90%? So the confidence level is the percent of confidence intervals that would capture the true population mean or population proportion if we took a look at all possible samples of a given sample size and made all possible intervals. So if our population is really large, let's say 2,000 students, and we selected 50 students, imagine randomly selecting 50 students and creating a confidence interval, and then doing a separate random sample of 50 students and creating a confidence interval, and doing that again and again and again until all possible samples of size 50 were constructed. 95% of those intervals would capture the true population parameter. Let's say that you constructed just one 95% confidence interval for the mean number of hours students spend studying for a class in a week. Does this mean that there's a 95% chance that your interval does capture the true mean hours of studying per week? Well, the answer is that's no. Let me explain why here. That interval that you constructed either actually does capture the mean or it doesn't. We won't know which. However, because 95% of all intervals would contain the true mean, we can feel pretty confident that the one that you just constructed contains the true mean. And this idea here is illustrated below. So notice we've got this one interval in red, and this interval did not capture the true population mean. Notice that it has 16 values that are below the population mean that's in green. And so when we calculate the sample mean, and the sample mean is this dot in the center, the sample mean is a lot lower than the population mean. And when we go out 2 standard deviations on either side, it doesn't quite reach far enough to capture the population mean. You might also notice that it says the percent here is 90%. Well, and I know that's not 95%. Well, that's because this isn't all possible intervals. Remember, the 95% confidence level, or whatever confidence level you have chosen, refers to the long run success rate of all the intervals. So if we constructed 1,000 intervals, this percent hit might be close to 95%. But the 95% refers to all possible intervals that could be constructed. So how do we interpret intervals in general? So this is the statement that you could write to interpret intervals in general. And notice over here it says true mean / proportion. You'd either have to choose the true mean or the true proportion. You wouldn't write true mean / proportion there. You'd have to decide whether you're working with the mean or proportion depending on the situation. So here's an example. It says we've constructed a 95% confidence interval for the mean number of hours students spend studying for classes in a week based on a random sample of 100 students. And the resulting interval was 15 plus or minus 5 hours. So we're going to interpret this interval and assume the conditions for constructing the interval have been met. So notice that we've got the 95%, and that might not always be 95%. It depends on the situation. We've got our lower bound. We've got our upper bound. So that's what I've highlighted or typed here in red. And then I've got the true mean. And then all of this underlined here at the very end is our context, the specific situation. So what about some wrong interpretations? Where can we go wrong? We'll continue to focus on this example of the hours spent studying. But here are 6 statements that are incorrect interpretations. And so I would encourage you to pause the video and see if you can figure out why those statements are incorrect. So here are the solutions to those 6 statements. So I would encourage you to look at the document that I have sent along with this video and take a look at each of those statements that were incorrect and these rationales for why they're incorrect. Remember that a confidence interval is about an entire population parameter, right? A population mean, not a sample mean or a sample proportion, population mean or population proportion. And notice that the confidence interval does not give us information about individual people or individual subjects and their, in this case, behavior of studying. It's a statement about an entire population. So hopefully this helped you. If you have any questions, feel free to send me an email.